Pozdrav svima, dobrodošli na webinar Google Developer Grupe Beograd. Ovog puta ćemo pričati o machine learningu, ali ćemo sačekati par minuta da nam se ljudi pridruže. Ovog puta imamo gosta iz Googlea, tako da verujem da će predavanje biti interesantno. Verujem da engleski nije problem, a bit će i nekih vežbica i nekih interaktivnih stvari, tako da spremite svoje telefone da tokom predavanja skenirate QR kod i započnete malu igru. Vidim da nam se ljudi polako pridružuju, tako da sačekat ćemo još možda minut, a onda ću uključiti našeg gosta koji će reći nešto više o sebi i krenuti sa prezentacijom. Ukoliko budete želeli da nam pišete, slobodno bez obzira na kojoj platformi pratite, pišite u komentaru i mi ćemo vidjeti i potrudit ćemo se da odgovorimo na sva pitanja. Ok, mislim da mogu da dodam i našeg gosta. Hello, Laurent, do you hear me?
Yeah, I hear you, Vladimir. Hi, can you hear me too?
Hello, yes, I can hear you very well. I hope guys can hear us good as well. So I just said that they can post comment regardless of the platform they're watching, because we're streaming on YouTube Live, LinkedIn Live, and our Facebook. So it doesn't matter what platform they use, they can post comments, ask questions, and we will try to answer questions. Great. I also told them to prepare their phones, because during the session they will have a QR code which they will scan and play around a bit. So exactly. Maybe for the start, maybe you can say a few words about yourself. We wrote a short bio, but maybe you can also introduce yourself.
Yeah, so I'm Laurent. I'm a developer advocate working at Google Cloud Paris. So I'm based in Paris. I'm in my 40s, so I have some experience in education solution. I was an ebook pioneer, so I made one of the first ebook devices over 20 years ago. So we launched the first ebook device in Europe in 2000. So that was a big brick of 1 kilogram. So I've seen, being a pioneer in ebooks kept me busy for 17 years. And now for the last 4 years, I've been focusing on cloud technologies, because while deploying ebook solutions in the cloud, I discovered that the cloud technologies were just giving superpowers to developers. So yeah, that's why I decided to focus now on cloud, and maybe it will keep me busy for the next 20 years also. So yeah, those are really great times for developers.
Thanks, Laurent. I totally agree, and I think all the technologies, development of the technology is speeding up, so we have a lot of new things popping up like every few months.
Yeah, or on my side, just Google Cloud itself, it's every day new features everywhere. It's gigantic. Yeah, it's you can get drawn in technology. It's just great.
Amazing. So maybe we can start the presentation. I'm not sure how much time you need. I guess we will finish until 7 p.m. and maybe we can leave some time for possible questions.
Yeah, about 1 hour. Okay.
Oh, nice. Great. Let me bring up your presentation, and I will remove myself for the moment.
Perfect. Shall I start now? Yeah? Everybody's ready? Okay. Yeah? Can you put a comment? Let's go. Okay, I'll start. So my goal today is to talk about machine learning, but machine learning from the point of view of a developer without any expertise in machine learning. This is how I've been discovering machine learning, applied machine learning for the last years. And this is just amazing. And my goal today is to share what I could see over the last years with you. Okay. I already did a presentation, so now working for Google Cloud in Paris. So it's the same time zone as in Serbia. Worked for 17 years in the ebook industry, co-founded a startup called Bookeen, and now 100% on cloud technologies. Okay. I love this quote. I still keep using it in my presentations because even after a few years seeing applied AI with machine learning, I still feel some kind of magic, right? When I see something developed with machine learning, I kind of know how it has been developed by experts, but whenever there's something new, it's always feels like magic. But we all know technology, right? We just scratch a little bit. This is technology, okay? So my goal is to show you many examples today, okay? So what is machine learning? This is my definition. So, and that's how I've been using machine learning for the last years. As input, we have data, but we don't understand what we have in our data, maybe, or we would like to extract insights. And machine learning is able to extract information from data. That's what I think is magical. Okay, but the real definition, so that my definition is a bit wrong. The real definition is that machine learning is a part of AI, and within machine learning, there's also deep learning, so dealing with neural networks. And this is where we are seeing most of the progress of the last years. Okay, so how does it work? About 40 years ago, AI is older than that, but about 40 years ago, a bit over 40 years ago now, researchers thought at the time, okay, what if we try to mimic the way our brain works? So they started to work on neural networks. And for that, they used, and we still do that for machine learning, they use many examples. Okay, and if you think about it, that's how we learn. As kids, we learn from our parents, from our sisters and brothers, from our family, our friends, our teachers, by watching, seeing examples. And from that, we automatically deduce something. We build connections in our brain. And even as adults, whenever if I want to renovate the place behind here, maybe I will watch a renovation video on YouTube, right? And we'll learn from that. Okay. And the magic is that from this, we manage to solve problems that we couldn't solve before. Okay. So why is it possible today? We inherit from a lot of science, of course. For about 20 years, we are now able to process a lot of data, and that's what we call big data. And for 10 years now, we are able to have access to very, very big computing power, and especially with the cloud. And this is why it works. And so if we take a step back and try to think how we can benefit from machine learning today, as developers, there are different ways. Of course, if you want to develop expertise, invest time to become an expert, then you can become an expert. It's just a matter of time, and then you will deal with neural networks. But in a company, it will be pretty rare when you will have experts, data scientists, machine learning engineers, and so on. And so if you have developer skills, you can still build smarter solutions with pre-trained models. So this is what I'm showing here. There are APIs that give you access to machine learning models that have been pre-trained on many, many examples, sometimes millions of examples. They are the state-of-the-art models, and they are available in the cloud with the highest quality. And And in between, filling a very big gap, you can find AutoML techniques. And with AutoML, and still without any expertise, you can build custom models automatically. Okay. And my goal in this presentation is to show you many examples of the machine learning APIs, what you can do right away, or what you can build, what custom models you can build. And internally at Google, we call them the building blocks because they're really like Lego bricks. You can take one of them and integrate it into your solution. Okay, so let's start with the machine learning APIs. Okay, so if you remember my definition, you have data as input, and this data can be text, pictures, videos, or speech. And from that, and those are the solutions at Google, from that you extract information, and sometimes, like here, the information that you're wanting to extract is actually your input, but transcribed in a different medium. Okay. And so we're going to see a few examples here. So I love to start with the vision API. So this is a very big vision model handling pictures, because this is a problem that I was trying to solve in the 90s. So I was a student in the 90s. And at the time, so machine learning was being worked on, but I had no idea. It was really in the research. So at the time, with my teachers, we were using convolution filters to try to find edges in pictures, and from that to try to understand which kind. So maybe here there are flowers and so on. So we could do something, and it could work in some cases, but as soon as we would use new pictures, it just failed miserably, and that was highly frustrating. And now machine learning for a few years is really solving that. And so if you give the same picture to the Vision API, you will get a description with labels and with a confidence score. Here on the right, you can see the JSON stream that you get as a response. And you see my picture is described. It's about nature, flowers, and so on with high confidence. Great. More precisely, it's able to match pictures in between them. If it's able to find a similar picture on the web, then maybe it will deduce a landmark from this. And here, this picture, as I modified it, I zoomed in, flipped it, I cropped it, I applied a color filter on it, so it's completely different from what's on the web. But still, it's able to tell me that probably this picture was taken on at Hobbiton in New Zealand, and that's correct. This is where the Lord of the Rings movies were shot. Okay, and you see, it's even giving me the probable latitude GPS location. Okay. More precisely, if there are entities, so experts call them objects, in pictures, persons or objects, they will be given to you with their location, with the bounding boxes, okay? And so here it's a picture of the cast of the Lord of the Rings in a restaurant, I think. And what I get here is that there are persons, you see. And even here, I get the location of pants and tops. So the t-shirts here, you see, the pants here, the person here in the back, and even the ceiling lamp here at the top. So that's pretty amazing to know exactly where entities are located in pictures now. More precisely, with faces. So if there are faces, here it's a 3D rendition. So it's not a human face. It's derived or close to a human face. And here the Vision API is able to tell me that there's a face here. If I want to do a close-up, it gives me the position of the eyes, the mouth, the nose, everything. And even more precisely, it tries to give me a sense of the emotion. And here what I get is that likely this face is angry, you see. And Gollum is always angry, right? So that's correct also. I have more features than that. I have the position in 3D. I have the depth of the face features. I can know how far the nose is going out of the picture and so on. Okay. and more features. Another problem still on pictures. So here, this is a screenshot. This is OCR, optical character recognition. So a vision model is now able to solve, to transcribe the text that can be found in your pictures. So pixels to text. Okay. So it's a bit boring because it's almost perfect. It's a problem that is really totally solved, and what I get is I get even the different levels of the text. So here, a block of text, a paragraph, the different sentences, the lines here, the different words, and also the different symbols. Okay, so what I always try to do with a machine learning model, every time I try, is to see the limit of it. Okay, so here this is perfect, but if I apply a perspective effect to the same screenshot, I still get the same text. There's just one difference. It's here, the double quote here at the end. There's one missing. It's a single quote, but it's perfect. Okay, it's almost perfect. Okay, so problem solved. But another problem, a lot harder. It's handwriting detection, and it is working amazingly well. It's a lot harder because it works with any handwriting, right? So here, this is a sheet of paper written by Tolkien himself. And what I get here is very good. There's one mistake here that is annoying. It's not finding really shadows, but shadows with a V. There's no linguistic analysis behind it. It's just OCR, pure OCR on handwriting. And if I want to be picky here, I would prefer this to be one single block, not two blocks, but still, I get the text. This is great. Okay, and one cool thing also with machine learning is that it keeps improving with time. Last year, when I tried this same sample on the same API, but on a previous version, older version, it was making 2 more mistakes. So now I have 2 less mistakes, and maybe in a couple of months, this mistake will disappear by itself. Because machine learning models can keep training, right? Keep learning and keep improving with time. They try to converge to human quality. And last, still on pictures, if there are famous entities, so a famous person or a famous object, then it's able to tell you so. So here again, I took a picture that I had never seen. It's unique. It has been used once in a Spanish newspaper. So I took it, I modified it, I zoomed in, cropped it, and here the API, the model tells me that most probably this is about Tolkien, and that's correct. This is Tolkien. The context of this picture is Spanish. That's correct. It's been used in this Spanish newspaper only once. And it's able to tell me that most probably there is a partial match with this image. And this is actually the image that I took, but there's not any single pixel in common. It's not the same resolution. I cropped the picture, I applied the color filter. So I find that amazing. And again, something very useful for developers, and I had no idea at the time. Here I get an entity ID. So it's a unique identifier that uniquely identifies J.R.R. Tolkien. And it's very useful because when you're dealing with labels, text can change, right? Or there are different ways to write something with text. And so J.R.R. Tolkien here is uniquely identified here with this ID. And this ID comes from Google Knowledge Graph. So it's also an API. As you know, we are constantly browsing the web to understand what's in the web page. And for 20 years, some experts at Google have been building a knowledge graph constantly, permanently, to try to understand what we're talking about in a web page. And for that, they have built a unique a graph with unique identifiers. And so, for instance, if I'm talking about Christopher Tolkien, the son, it's still Tolkien, the person, but it's the son, and it's a different ID here. Okay, it gives you more insight. For instance, page with matching images or visually similar images. So for instance, I will get people in a forest or persons against a tree. Okay, and sometimes you can find very funny things because the pictures are very similar, but it's not the same place, it's not the same person. Okay, so I told you it's a cloud API, so it means you can use it on the web. You can make a web request, but it's also an RPC API. All APIs at Google are RPC APIs, and so we also propose open source client libraries. I'm pretty sure you will find one of your favorite languages here. For a couple of years, I've been focusing on the Python language, so I will show you some Python samples. And the way to use that is always the same. You create a client. So here, you provide the input, the content, so a picture here, okay, with the URI, so the location of the picture, and you call the feature you want, face detection. And it's very, very fast. Almost immediately, you get the results in 1 to 2 seconds. And here, you can browse all the faces in the picture, and you can know where they are located and what the emotions are. Okay, we will do a demo altogether a bit later in the second part of this presentation. So keep your smartphones or laptop connected. Wherever you have a webcam, we will do a demo together. Okay. So now I'm moving a bit more quickly on this one. It's the video intelligence API, a video model able to tell you what's in a video. You can extrapolate from what you've seen on pictures. The features are a bit similar, but you have one more dimension, time. Okay, a video is pictures with time. So the additional features that you get is that you can identify the different sequences in your video whenever there are shot changes, right? So you can understand how the video is structured. You can filter the video. You can detect object, track objects. So the difference with pictures is that if you find one object in one frame, in the next frame you're able to track the same object, and if they are different objects, you are able to see how they are moving. Okay, you are able to detect logos, persons, poses. So you can now get the skeleton of the people in the video and so on. Okay. So just it's always the same principle. If you're able to understand what is in your data, it means you can index it, right? So let me show you this demo. So it's a web demo using videos. So here, for instance, I select this video, and you see the results here, the annotations. So those are the labels, and you can see that there is a computer monitor here. Okay, that's correct. You can extract the text from the speech here, and you can also follow, detect and follow objects. So let me try, for instance, I've seen that there's a horse here. So let me show you something that amazed me. So on this part, it's the Rebel movie. I don't know if you have the right bandwidth to see, but it's a 3D animation that is morphing from 2D. So you see, and so it's a 2D drawing, then it's the 3D animation in a morph. And here the video intelligence API is able to detect the character, so a person here and the horse. And it's able to track it in this sequence. And this is something I wouldn't be able to do at all with just algorithms. Okay, so remember, you're able to index virtually anything thanks to machine learning, and it means you can search it and find it pretty easily. Okay, so here is an example. And also I've written a code lab if you'd like. Oh, I forgot to tell you. I will give you the link to this presentation at the end So you will have everything, all links with QR code or with a short link. So you can focus on this, and I will also give you links to tutorials and so on. Okay. So here, how to track objects. So you create a client, a video intelligence client. You specify that you're interested in object tracking. You can limit, if you want to go faster, to some parts of the video, the analysis, and you just call annotate video, and that's it. And of course, the result is not real time because it takes some time to find the different frames and analyze them and send you the results. But it's shorter than watching the video, of course, and results are once again amaze me. So here's an example. On my GitHub, you will find how I can create animations. So this is a GIF here, and on this GIF was automatically extracted from the video. It's a sequence where there's this larva, this insect larva, right? And it has been automatically identified as an insect, and so I just created the GIF from that. Okay. Okay, I'm just checking if there are comments. You can ask questions. If they are relevant, I will try to answer them right away or at the end. Okay, so let's go on. We have seen everything on, or most of what exists on pictures and videos. Okay, so now, and that's what I should have started with, but for personal reasons, you understood I love the Vision API, the natural language API. So it's a very big field focusing on text, and that's actually what all researchers worked on first, because on computers we'll deal with text mainly, right? It's easier for us humans. So the natural language API, so it's a big field called NLP, natural language processing, is actually solving natural NLP problems with machine learning. Okay, so let me show you a few of the insights that you can extract. So it works at different levels, full corpuses of text, or full articles, paragraphs, sentences, even words or entities. Okay, so I'm just showing you an example with one sentence. So on this sentence, of course the NL model will tell me this is English, okay, but it's able to give me the exact syntax, okay, with all the different relationships between all the items, even the punctuation. Over the last 20 years, I've seen companies working only on this problem, and they didn't even manage punctuation. So the machine learning model is able to do almost everything. A very cool feature also is that you can get dilemmas. So for instance, it means you can get rid of tenses, plurals, and focus on the canonical form of the items. So it means you can really understand precisely what's in the text if you want to work at this level. Maybe in a company you won't get that far, but you may be interested in detecting entities, understanding what we're talking about. So it's a bit similar to the labels in a picture, but here the labels are entities, so groups. So here, for instance, I have 3 different groups in this sentence. In red, I have persons. Tolkien is a person, a writer is a person. Okay, so this is the kind of result I get for this sentence. And what blew my mind here is that if you have a look here, the MID, so the identifier for Tolkien here is exactly the same as before when I had Tolkien in a picture. Okay, so it means I can work with the same entities in text, in pictures, in videos, because it's all relying on a gigantic knowledge graph. Okay. The second group here in green is British, that is mapped related to location, to the United Kingdom as a location, and the 3 books here at the end are each detected as a work of art, and that is perfect. For entities, maybe you can, as a rule of thumb, you can remember an entity is a famous person or famous object entity that has a Wikipedia page. Almost all the time you will have a Wikipedia link here. Okay. And also a very yeah, Also, something very interesting that is used a lot by newspapers. We have gigantic archives from last century that they just could only scan because computers didn't exist. They can automatically classify content from that. So if I give this sentence to the NL model, it tells me that at 97% it should be classified under books and literature. That's perfect. And I even have other suggestions. Okay, so thanks to that, companies with big corpuses of text are able to automatically classify, and that's a different way to browse the information. And finally, like in pictures, like with faces, the natural language model is able or is trying to detect sentiments, can perform sentiment analysis. So to try that out, I used two different reviews. One from the New York Times for the Hobbit, for the book, and one from a social network from Goodreads. The first one is very positive, and the second one is very negative because Pauline here, she hated the book. And what I get works really nicely. I get scores between -1 and +1. These sentences come from Pauline's review, and these sentences come from the New York Times review. And of course, I didn't show it here. There are many, many neutral sentences because most of the time we are speaking in a neutral way. Okay, so this can be very interesting because it means some companies are using that to understand how we are talking about their company, we are talking about their product, and they can also see the trend over time. So some companies are just checking all the tweets about them, all the Reddit messages and everything. Some companies also are processing customer emails. And for instance, if you process customer emails in the morning and you handle the negative emails first, I know one company in the UK was doing that, you are more efficient because you are dealing with problems as a priority. And maybe emails which are very positive, maybe you can wait a few hours or read them in the afternoon only. Okay. And so some companies are using that to know how they're doing and also to optimize their customer service. Okay. The way, here's an example how to use it. You create a client, you provide the document. Here it's text, and you can call analyze sentiment. So it's almost the result is very, very fast. And here you can deal with the different sentiments that have been found. Okay. The other machine learning model relying on working on text, you have all used it somehow, I'm sure. It's Google Translate. So it's available as the translation API, but I've never met anyone who has not ever used Google Translate. So it works on text, on HTML, and it is giving result translations not like professional translators, but almost, and it is converging to. So what I can share with you is that 5 years ago, so in 2016, I was not working for Google, but I was using Google Translate as a simple user, a professional user. I was mainly using Google Translate to get translation from Chinese or Japanese into English because I couldn't understand anything. It was working okay before that. And suddenly in 2016, something happened and the results were amazing, very good. And I understood what happened when I joined Google is that 5 years ago, the Google Translate team switched from a statistical model to a machine learning model. And the quality just went from here to here. And for 5 years, the results just keep improving. So with more languages, of course, that are just getting better, but it's improving. As I told you, it's always training and it's learning and understanding new stuff. And maybe you are helping. So for instance, if you're using Google Translate and there's a translation that you don't like, maybe from English to Serbian. If you say that you don't like the translation is not good, you are helping the model, because it's like a counter example. It's okay, I know that this translation is not good, so somehow the model will converge to a different result, and very often a better one. And some users also take the time to give a better translation, and that's even better. In this case, the model will converge to better results even faster. And so the translation team has been monitoring the results for forever, and we are getting closer to professional translators. And I'm pretty sure you have seen these results. Okay, here's an example in Python. You have more comments than code here. You create a client and you call translate. That's it, done. You have the results. And for instance, so not in Python, but Airbnb, they are using this API for virtually everything, because the vast majority of their users, when there's a host and a guest, they don't speak the same language on the web platform, right? And so when a host puts a description of the place they want to rent, when a guest watches the description, it can be translated to virtually any language. Okay, so almost 100% of what Airbnb does for their system is being translated with this API. Okay, now speech. Two APIs about speech. So the first one, you speak, you talk, and the model is able to transcribe it into text. Okay. So maybe you didn't realize, but this is the first step, and this is why we have so good assistants. So maybe you have a Google Home or whichever your phone. I'm pretty sure you have an assistant that is working with machine learning on it, right? And this is why it works. It's because you can speak to your machine, to your smartphone, to your assistant. Your speech is transcribed into text, and the text can be analyzed with the previous natural language model, right? And we can understand what you just pronounced. Okay. So I won't get into the details. Maybe I will. So it works in real time. Maybe one feature that is also amazing, and it's related to machine learning. As you know, machine learning learns from real life examples, actual samples. And in real life, we have noise, right? And so if we are able to converge to the results we want, and if we have noise in our input, then it means that the model is robust to noise. And that's what we have here. The speech to text model is very, very robust to noise. You can speak, you can send a speech to it, and if there is some surrounding noise, it will still keep working. And you will see, I'm gonna do a demo also with a different noise, but it's pretty amazing because once again, over the last 20 years, I've worked with companies use their solution that were trying to solve this problem. And when there was noise, it didn't work. Maybe you remember 10 years ago, maybe 5 years ago, you could call your bank and you had to pronounce words on the phone to say, I want an advisor. You had really to articulate everything, otherwise it would do something else, right? Now it's the past, and maybe you didn't realize because it's so natural. It was pretty amazingly well. So once again, if you're able to understand speech, you can index it, and one of the features is that you can get the timestamps. And so it means you can index every word in your speech and do a search for any word. Okay. So here, this is a tutorial that I've written that you can find on the CodeLab platform. And I recorded myself pronouncing a French poetry. Maître Corbeau sur un arbre perché tenait en son bec un fromage. Okay. So this is my actual voice that you can find there. And here is how you can use the API. You create a client, you call recognize, with the configuration that you'd like. So you can help, but there's auto detection, language auto detection is possible now. But this is what I did. So I said, okay, this is a speech in French. I want the results with punctuation, also something that other companies couldn't do previously. And I wanted the timestamps. So I just give my, it can be a WAV file, a FLAC file, or whatever. Just specify my input, and then I get the transcript. And at 93%, everything, and this is the right. And I have a uppercase. I have the final point in my sentence and everything. Just amazing. Okay. And now the other part. You have text and you want your text to be pronounced. And that's the final test, the final step of an assistant, right? You can talk to an assistant, you will be understood, and then you get an answer. You get an answer that is pleasant to hear. And maybe I can share with you something. So 21 years ago, when we launched the first ebook reader in Europe, I worked for a few weeks on text-to-speech. I integrated a text-to-speech engine, and on this first ebook reader, you could press play and you could hear the text. I was very proud because it worked. Technically, it worked perfectly. Every word was highlighted and the text was read aloud. We launched the firmware update. Waited and nobody used the feature or used it for 30 seconds. But it was obvious at the time because it was a robot pronouncing the text aloud. It was Alice in Wonderland. It was really annoying. And now it is, and I have to admit I'm jealous, this is the most advanced machine model I've seen. The one from DeepMind. Maybe you know DeepMind. It's our subsidiary was able to build neural networks from scratch. And they have done something with the Wavenet technology. They are able to generate natural voices, but really very, very natural. It's the most advanced. I'm not sure we can do better or some subtleties. There are research articles about it if you're interested. So it's called Wavenet. Okay. So it solves three problems. First, it's very pleasant, human-like. It's real time. Or it's better than real time. Sorry, two problems. It's better than real time because in 1 second you can generate 20 seconds of speech. So it's 20-fold the speed. Okay. DeepMind. Maybe you know them. They have beaten the world champion for the Go game a few years ago. Last year they have beaten gamers, world champion gamers for StarCraft. So they're really, really good. So let me try one thing. I am now trying to share my audio with you. One sample here has been generated by Wavenet, and the other sample is the original voice from the actual person. Can you guess which one is the original one?
She earned a doctorate in sociology at Columbia University.
So I hope you can hear.
She earned a doctorate in sociology at Columbia University.
Okay, so it's the right one. The right one is the original one. It's almost impossible to make the difference. Of course, with longer sentences, you can tell. And for instance, if you have a Google Home, it is using a Wavenet voice. Okay, and you can use these voices. Okay, so let me show you. Let me try something with you. So I'm going on Google search. Maybe you didn't notice. Okay, I'm going to the English side, but it works in French. But maybe you don't speak French, so I will do it in English. I'm going to do a search just with my voice, but I'm going to speak English with my thick French accent. Okay, let's try. Okay. What is the temperature in Belgrade?
It's 11 degrees in Dublin right now.
Okay, so I mispronounced the last one. Let's try again. What is...
Here's a matching video.
what is the temperature in Paris?
It's 17 degrees in Paris right now. There is currently a yellow thunderstorms warning in effect.
Okay, so I don't know if you could see it because it's real time, but in real time, I got the results. As soon as I started to pronounce one word, I got a suggestion, and it's the model working in real time. And I was working with a very thick accent. Maybe a British or an American person wouldn't understand me or would say, sorry, can you repeat? But here it's been able to transcribe what I said. So somehow it shows that the model has understood the essence of speech. Okay, maybe it has made the similar connections that we have in our brains. Okay. And here's another tutorial that I've written. If you'd like to generate text, just these lines are enough to generate what is the temperature in Sydney with the Australian accent and so on. It works, of course, with I don't remember how many languages now. There's over 100 different voices, and the result you get it right away. What did I want to say? Yeah, okay, let's move. Okay, so just these lines lets you generate WAV files, and you get the results that you can output anywhere. Okay, so we've seen what you can do, or most of what you can do with pre-trained models, machine learning APIs. But in some cases, it will not work in your business use case, maybe, because maybe your use case is more precise. Okay, so let me give you an example. And this is where AutoML techniques will maybe let you solve your problem. So if I take these two pictures and give them to the Vision API, I get almost the same results. Okay, you see, it's almost the same. Because basically those are clouds in a sky, okay? But if I want to build a weather forecast application, okay, because from the shape of the clouds, I want to deduct and work with people from the countryside, and maybe I can build an app and automatically predict what's the weather going to be like in the next hours. Then I need to be able to detect that it's a cirrus, it's an alto cumulus, right? And the Vision API is not able to do that. But you can do that automatically with AutoML, and here AutoML Vision. So here so here this problem is an image classification problem. Okay. So how does it work? Unlike the APIs, here you need to work a little bit more. You need to build a data set, right? So in our example, you need to provide pictures. But then everything else is automated. And you can launch a training based on your data set. And then iteratively, because we make mistakes, so you will make maybe 1, 2, or 3 trainings, and then you will have a model that you can use, and that is giving you very good results. When you do that, you have 2 different options. If you want the best quality, if you want a state-of-the-art model, then you can generate a cloud model, okay? And this cloud model will be huge and will stay in the cloud, but will provide you with the best results, the best accuracy, the best predictions. And you will then have 2 ways to use it, either with batch processing. So you input a lot of documents or images, and then it will do that as a batch processing, and then you will get the results. But you can also expose, just like the other APIs, you can expose your own private API. So it's going to be your AutoML API, and use it live in real time. Okay, I've done that. That will be the next demo we will do all together. There's also another very, very interesting way to do that, especially if you want to use your model elsewhere, not in the cloud. You can build an edge model. So the edge model will be a lighter model, so it will not be as accurate. It will be smaller, so it will not be as precise, but you're going to be able to export it and use it elsewhere. And you can use it in a container. You can use it in a mobile application on Android or iOS, so with the native, so for instance, with the TensorFlow Lite format. And also something else that I've used, I'm not an expert, I don't know how to do neural networks, but I've built a model and exported it as a TensorFlow JS model, and I could use it in a web page. And so it means that once I have my model in a container, in my web page, in my application, I can use it in real time and also offline. And here, so this is what I had in my web page. I have my web page, and I can do everything in real time. So let's go on with our example. So here, this is the data set that we did based on cloud images, and we gave samples. We gave labels, sorry, to every sample. So cumulus and so on. So you see, you don't need thousands of samples with 100 or 200 pictures here. It's really starting to work pretty well. Oh no, I will not show you live because it will take too much time. Okay, but you will find everything in my links. Okay, and some tutorials. Okay, let's move on. So once you have your data set, you can launch a training. So here, this is the first training that I did in 1 hour, one compute hour. So this is distributed, of course. And thanks to that, I got results pretty quickly, and it's almost always the case in my experience, I made mistakes. So there were wrong labels in some pictures. And with this first training, and you can see here, I could realize my mistakes. So I fixed my data set and launched a longer training. And of course, the longer the training, the better the results usually. But also a cool thing with AutoML is that the training will automatically stop whenever it converges. So it's not using your budget. So this is where you will maybe spend money. It's not using your budget for nothing. Whenever the results are good, it just stops. Sometimes I ask to do a training for 24 hours, and it stopped after 2 hours because the results were good. And so here I have a very good model with 90% accuracy. Okay, here's one tool, especially for classification, to understand how well to evaluate your model, to understand how well it's doing. Here it's doing pretty well for cirruses, cumulonimbus, cumuluses, even the altostratus at 80%. But the altocumulus is not doing great. Almost half of the time, it's misdetected as something else. And so thanks to that, you can go back to your data set and understand. And I have two kinds of mistakes in this data set. First, I have a lot less pictures of the altocumulus. Well, I have less, not a lot less, but less. And second, the pictures, most of the pictures look alike. They're very, very similar. And so there's no point in giving many examples if they are similar, right? And so maybe building data set is an art and will become more of an art. You have to understand how to build a data set. The data set has to be balanced, right? Unbiased. You have to avoid the bias, or otherwise your model will just give you biased predictions. Okay. And I have my model now, and then I can expose it as an API, upload a picture, and it's giving me this prediction on a picture that's coming from my smartphone, never seen by the model. Okay, so I showed you what you can do with image classification, but it works also on videos, on text, and also on structured data like CSV files or Excel files or whatever, or databases. Okay. And you can do all those features. So those are non-problems that you can solve automatically thanks to AutoML. Okay. Even one that I didn't show is pixel segmentation. You can understand in a picture automatically with the training which pixel belong to which entity, or maybe the background, or it's used by some companies to detect on bird's eye views where there are swimming pools, where there are rooftops, and so on and so on. Okay, it's endless. It's up to your imagination. AutoML also, it's been announced recently, a couple of days ago, is part of Vertex Ai. So Vertex Ai is a big AI platform, and AutoML is part of it. And so here maybe you can understand better what you can do on images, on videos, on text, and on structured data. Okay. The only one that is staying independent is AutoML translation for different reasons. Okay. So let's do a demo all together. I would like to. I don't see you. I don't know where you are in your couch or whatever. Okay, so I'd like to see how well you're doing. I hope you are all doing well, and I hope I'm not boring. So we're going to use the Vision API from your smartphone or with your webcam, and also my own AutoML model. So I've done a model with pictures from myself, from my colleagues, and also from previous conferences, from attendees who gave me their authorization. I've built a model of people with the tongue out, of people yawning, and of people sleeping. Okay, and I'd like to try to detect that with you. So here, this is my architecture. From your smartphone, you're going to be able to send me selfies. Whenever a selfie is uploaded, it will call a cloud function in Python. I will show you the code. And then it will call the Vision API to know whether there are faces. If you take a selfie of your feet, it won't work, right? It will say there's no face. And also it will use my own private AutoML API. Okay, so let's try this. Okay, I think there's a small delay, so I will give you some time. Maybe Vladimir, you can copy in the comments the URL. So you can flash this QR code, or you can enter the URL. It's bit.ly/mlbograd. bit.ly/mlbograd. Okay. So I give you some moment. I think there is something like maybe 15 seconds of delay between my live stream and your live stream. So we would be a bit delayed. Okay.
Yes.
So
maybe wait a few seconds.
Okay.
And we also had another question. I'm not sure we will have time to show how to use speech to text and then text to speech combined API. So maybe
no, but if I don't, I will stay a little bit after I'm finished to answer as many questions as possible. But then if you have other questions, or if I can't understand everything, please ping me on Twitter or LinkedIn, and then I will provide you with answers. Okay. I'll try to do as much as possible with you. Okay. Okay. So Vladimir, were you able to copy paste the link in the chat? That's the fastest for the participants. Okay, so let's move on. Anyway, you will still have the link here. So you see, if you authorize, there's a lot of sun coming right now. If you authorize the webcam, you can take a picture and send me a picture of you and try whatever you want. I will try that. Okay, so I'm trying to express an emotion, and I want to see if the Vision API is able to process it. And as you can see, with all 100 or over 90% confidence, it's telling me that I'm surprised. But if you remember, it's able to tell me where the nose, the mouth are. So this is why I'm going to add a mustache to every one of you. Okay, let's try again. Okay, so this time I'm supposedly happy. Oh yeah, I forgot. I wanted to. Okay, let's try a more difficult one. Let's try to be angry with the head like this. Okay, I don't know the result. Oh yeah, I am angry. My face is skewed, right? But I'm using the orientation of the eyes, and so this is why I can put a mustache in between the nose and the mouth here, with a pretty good orientation. So now I'm going to move, and you can still use this URL if you're coming late, bit.ly/mlbograd. I will leave the demo for this evening. Okay, and so you'll be able to try the AutoML model. I will stop it tomorrow. Okay, so you can try for the next hours if you want. So this is my model. So I used a couple of 100 pictures for this model of people with the tongue out, people yawning, people sleeping. So try any of these. Either there will be a match, and of course I'm using a threshold. Either it will tell. I don't know. I'm not sure. Okay. So feel free to put out your tongue to me. Okay, so I'm first, and here I'm using the colors of the French flag. So blue, white, red. I wanted to say it in French. And as you can see, I'm getting the right label that I trained the model on. I have the tongue out, and the confidence is very, very high. Let's try another one, and you can keep trying it. Okay, so I'm yawning, and it works, keeps working. But there's one caveat. You could say that I'm cheating because I trained this model on pictures of me. So yes, somehow I'm cheating. So let's check out how it works with your own pictures, okay? So here, Vladimir and myself, we are happy it works. So that's the Vision API. Okay, here I'm surprised. Here, nobody's sad. Angry, Vladimir and myself are angry. Okay, so here you see there's a mustache could be better. I'm checking if there are more attendees. And here, people with the tongue out, yes, it works. People yawning, people sleeping. And also, if you remember, I'm the only one with glasses. Okay, so here, there would be, if some of you had glasses, you would be here. Okay. So you see, let me show you the code. Just this. So this is the cloud function that I've deployed. And I'm saying that I want safe search detection if ever there was a zombie coming and attending, sending a selfie, it would be detected. Face detection to know that I want to where the faces are, and object localization to detect glasses, but I could detect ties, scarves, tops, t-shirts, and so on. Okay, so those are the features, and this is just the request that I sent with annotate image, and I have the results right away. You could see this is real time. It works. It's very, very fast, and then I can do the processing on the selfie and find the face. If there are different faces, I will take the largest face or the face with the most pixels, and we'll add the mustache. And you could see it's a serverless architecture. It worked very quickly. Okay, so let's move on. So I'm running over time. So maybe quickly, there are four. If you want to evaluate your model, there are 4 cases. Experts are calling the positives the predictions, the results that you get. Okay, if you expect them, they are true positives, the right results. But if you don't expect them, then they are false positives. And similarly, in a symmetrical way, the results that you don't get, if everything is perfect, you don't get them, you don't expect them, they are the true negatives. But if you get them and don't expect them, if you don't get them and expect them, they are false negatives. And those are the 2 kinds of mistakes a model can make. Most of the time, the false positive are very obvious because you get the results and wow, that's not what I want to get. Okay, there are 2 metrics important for a model. The precision relates to the quality of the model, and you want with the precision metric, you want to minimize the false positives. And so if you want to focus on quality, maybe you will put the threshold pretty high, right? But if you're doing a search engine, then in this case you want more results that are still relevant. And so you will focus on the recall metrics, with the recall metric, you try to minimize the number of false negatives. Okay. How does it work under the hood? So I will go quickly because I'm not an expert. I just can tell you what I can see under the hood. There are three main techniques. So one that is very specific to Google. There is a research paper called NAS, Neural Architecture Search. Before even launching your AutoML training, we are doing a first training, actually many different trainings to see what's the best architecture for your data. Okay, it is using a lot of computing power, so this is why a training in an AutoML training has to be paid for, because this is the added value maybe here, and it will give you the best architecture, the one that is giving you the best results and the fastest results also. Okay. One key feature of AutoML, and it's known by the experts, so other companies can propose the same, and that's at the heart of AutoML, is transfer learning. So the way transfer learning works is the following. It is based on an existing neural network, so for instance, the Vision API. And when you provide your data set, transfer learning builds additional layers. So they are called hidden layers, but these additional layers, they specialize the model for your own use case. And this is why, for instance, I've been able to detect certain types of clouds because I provided new data and I got new connections here. Okay. And another key feature specific to Google is that we are able now automatically to fine-tune the hyperparameters. So they are parameters that cannot be learned from the training, but that are related to the data and the type of the problem type. And for 10 years, experts were fine-tuning the hyperparameters and were getting the best results. But now we have an algorithm that is doing better than experts, and it's been checked on all the data sets from the last 10 years. And it's also available if you are an expert and if you want to try that out. It's available as an API. It's called, and it's in the Vertex AI platform. It's called Vizier. Okay. And what it does is that maybe experts would find Optima here, some good results, but Vizier is able to find a better one. Okay. Let me show you a video. So this is not image classification, but this is object detection. And it's running in a web page, so I recorded the video to go faster. But if you remember, I worked in the ebook industry before. And so this is an electronic board for one of my ebook devices. And on a production line, maybe at the time, I wanted to detect defects or make sure that we had all the components. And so this is working on a web page, and I have a webcam here. I just put my electronic board below, and it's able to detect the components automatically. I never made any neural network. I just had to give 100 pictures of electronic boards where I said, okay, here are the components I want to detect. And AutoML Vision automatically can do that. So here, this is an edge model that I trained, and it's giving me very good results. Sometimes it's not able. Here, for instance, it's missing this one, but it's because there's a very close by component here. So, but I just have to give this example, and the training will improve. Okay. And also the cool thing is it's really real time. Here, while I recorded this, so I was consuming on my laptop quite a lot of bandwidth, it was still able to do 4 to 5 predictions per second. But you can, the latency can go as low as a few milliseconds if it's using a GPU or a TPU. Okay, there are many possibilities. It can run on a Raspberry Pi with a TPU key, for instance, and it will give you predictions in 5 to 10 milliseconds. So amazing real time. Okay, so I'm working on that and also on something else. Follow me if you'd like to know more about it. If you want to do more machine learning, it's a whole universe. And if I was in my 20s, I would spend 100% of my time on it. but unfortunately, I don't have the time anymore, or not that much. So first of all, I showed you building blocks, okay? But there are other solutions. So one of them is Vertex Ai, and on Vertex Ai is you can do everything. You can use AutoML, but you can also build your neural network, have machine learning notebooks, build handle your own machine learning pipelines, and so on. So this is called MLOps. It's a new job, right? There are engineers who are specialized in MLOps. Another platform is Document AI. So Document AI is using OCR and handwriting detection, but is also able to detect tables, forms, and from that, building on top of that is able to analyze invoices, receipts, some government forms, and ID cards and everything. So it's just the start, but it's already huge and just will keep growing up. Dialogflow also has been here for a few years, and it just keeps improving amazingly for the enterprise. With Dialogflow, you can build a chatbot that is very pleasant to work with, that will understand you, that will analyze what you said, and that will provide you or guide you through a graph. Okay, and also call center AI, very dedicated to a vertical. There are very big companies using all the solutions altogether for call centers. Okay. I keep this slide, but it's actually from a couple of years ago, just to show you the evolution. So 3 years ago, TensorFlow was already the favorite machine learning repo on GitHub. It's open source. If you want to deal with neural networks, you can use it. Now it has integrated Keras, that is a high-level API. So I never used TensorFlow per se because I'm not an expert, but it's just a matter of time. If you want to do it, you can do it and go. And over time now, you can say that there are two main ecosystems. TensorFlow, huge for everyone, and maybe more dedicated to engineers. PyTorch also has been very successful. I only hear about TensorFlow and PyTorch. Okay, so you can try, depending on how much time you want to invest. Try TensorFlow. You cannot be wrong. And if you want maybe be even more specific, PyTorch is a great solution. Okay, time to wrap up. So what have we seen? We've seen that you can use machine learning APIs, and it just takes hours. The first demo I made, when I made a prototype, I wanted to see if I could put a mustache on faces. It took me a couple of hours in one afternoon. So using and all the code labs that I've written or my colleagues have written, you can do them some of them in 10 minutes, some of them in 20 minutes, and you can see all the different features. Okay. With AutoML, you need more time because you need to build the data set. So it's more a matter of days. And for instance, in the two cases for the cloud data set I've done, or I reused the cloud dataset. But for the image classification for the tongue out and so on, so I built it from scratch with pictures. It took me 2 days, but I did it over 4 steps, so 4 half days, because every time I saw mistakes, and every time I had more samples, I would improve the dataset. So 4 half days, 2 days. And it's been some time that I didn't touch it since last year already. Okay, so keep in mind maybe 2 days before you can do something with AutoML. You can get some results very quickly after hours, but before you can have a nice prototype, maybe let's say 2 days. Okay, and machine learning, of course, you can do everything. It's a matter of weeks, maybe months or years. If I was starting with neural networks, maybe I would spend the rest of my life. But then you will specialize in some areas, right? You cannot know everything in AI. It's impossible. The difficulty with machine learning APIs, absolutely zero difficulty because it's an API. Just make a request. With AutoML, the dataset is the difficulty because it's the quality. The quality of your model will depend on the quality of your dataset. Everything else is automated. And if you want to become an expert, you have to deal with everything, data set. So think about using cloud technologies because it will make your life a lot easier. You can develop with TensorFlow on your laptop, but at some point, when you want to go faster, or when you want to deal with real data, big data set, then you will have to do it in the cloud. Okay, so those are pointers on the different products I've shown. Here, those are pointers, but I will. So you can find these code labs on the Code Labs platform, g.co/codelabs. If you have a look for machine learning, you will find them. They are available. So I wrote most of them in Python. A colleague of mine wrote them in C#. Maybe there are some in Node.js and so on. And on my Medium and GitHub, you can. So if you, my handle is Picard Paris. My name is Picard. I live in Paris. Picard Paris on Twitter and Medium, GitHub, and so on. You will find some examples of how I could auto-generate summaries of videos like here, how I could extract animations of the entities found in a video, and also the face and the mustache demo that we just did. You can see the code. It's less than 300 lines of code every time. Just a couple of hundreds lines of code, and it works. So I just love that because less lines means less bugs. So that's just great. Okay. Another resource that is pretty cool, if you go on bit.ly/ml dash comics, it's 2 comic books made by Google AI. And if you want to know more about AI and deep learning in particular, you will find these 2 comic books pretty nice because you start from scratch and then you will rediscover or refresh your memories about all the different terms in machine learning. And I just keep watching this comic book because I'm not an expert and I forget about terms, and it's a very nice refresher. Okay, so here's the link. You can find this presentation on bit.ly/slides/mlmagic. Okay, you can send me feedback as you want. Here it's a form. You can come back to me anytime. I hope it was a nice overview to you. My goal was to inspire you, so ideally, I hope I give you ideas. That's my grail, my ultimate goal. But I hope at least that you learn a few things. So thanks a lot for having me, and now I think it's time to try to answer as many questions as possible, if we have questions. Okay.
Thank you, Laurent, for the interesting session. I was receiving during your talk. I was receiving messages like, "Hey, I'm not into machine learning, but this is really interesting, and I can understand here and there." So it's I think it was really useful.
Okay.
Maybe.
Yeah, let me give you the link so you can copy paste it in your chat. Okay, so I give you the link in the private comments. Let me check what I can answer. Will you teach the exact way how to build and deploy, showing us live? No, unfortunately, I don't have the time. But yeah, have a look at the pointers that are in my presentation. Everything is pretty simple, and you will find all the different steps. Can you please show how to use speech to text and then text to speech, both combined API? So there are code labs for that, right? So step by step, so you can use them. Maybe before you do a code lab, maybe I'd like to show you something. So let me go back. Whenever possible, Google tries to give you demos. So yeah, so for instance, text to speech. So I'm opening the product page, okay? And very often there are online demos that you can try. So here, and maybe before you try a code lab, that's a way to test the model. Here you can find all the different languages. So let's see if there. I should have checked before. So there's not Serbian yet. Is there any language that is close to Serbian? Okay, so
maybe try Croatian or
Croatian,
Bosnian.
So sometimes it's the how do we say it's which H?
C.
Sorry?
It's on C. CR.
Oh, okay. No, it's in the native language. So sometimes it's not the same letters. It doesn't start.
Oh, okay. Then H.
Yeah, that's what I checked. I thought, yeah. So Croatian, not yet.
Yeah. I don't know, like Bosnian,
okay.
Serbian is.
Sorry, let's try Romanian. And so here, oh yeah, but I don't speak Romanian. So here, this is how you select. You can say basic is the previous models that were somehow handmade, right, from phonemes. And you can hear because it sounds like a robotic voice. But Wavenet voices are the ones that are very much human-like. So yeah, but or maybe let me. Yeah, that's funny first because there is sometimes different accents, the French accent, the Canadian accent. So let me try something in French, but hear it with the Canadian accent. So I'm going to pronounce it with my France French voice, and you will hear it with the Canadian accent. Okay. Okay, let's try. Okay, the first. Okay, I'm not a robot.
Bonjour les amis, j'espère que vous allez tout bien.
So and I would pronounce it. Bonjour les amis, j'espère que vous allez tous bien. Okay, so let's see with not the Canadian one, but the French one. And there are, of course, male and female voices.
Bonjour les amis, j'espère que vous allez tous bien.
And I would say, bonjour les amis, j'espère que vous allez tous bien. See, it's very close, very natural anyway. So here, this is how you can transcribe text into speech. And the other one, anyway, if you want to try it live, speech to text I showed you. You can test it. You can test it with Chrome. And so here, let's try maybe with the microphone. Do we have Serbian? No, sorry, Croatian. Oh, there are a lot more. So I guess this one is Croatian.
Yes,
but
yes.
I don't speak Croatian, so so it will yeah. Yeah, so it's silly to try that. But you can try that, okay? And yeah, and among the new features, also here it's in beta. For some languages, if there are several people speaking at the same time, the model is trying to separate them and give you a transcription of the different persons. Once again, just mind-blowing. Okay, so have a look at these different pages. Maybe you just can try, see what's available, how good the results are if they are pleasant to you. Okay, so we did the demo. Do we have more questions? After all uploading the image, it shows processing, nothing happened. Yeah, maybe my demo is not perfect. So maybe if you refresh the page and try again, it will work the second time. Maybe it's not error prone against network failures, or I don't know, or maybe low bandwidth. I don't know. It was okay. Just a few seconds. Oh, so it worked for Marija and Vladimir. It's enabled to detect my expression. It shows none of the above. So one thing that I noticed is that And that's true for all the data sets. Somehow, so first, the data set must be as real as possible, as close to real examples, right? Otherwise, it will not work, because if you train it on some examples and in the real life, the samples are different, very different, then how can it work, right? So maybe you were in a condition that I had never explored. I know that in conferences, very often we were in the dark on smartphones, and so it's working pretty well. Maybe we're in different conditions. Maybe with the sun like this, it doesn't work. I don't know. But I'm interested to know if you can ping me later on, or send me the picture that didn't work, or just let me, if you check the box, I will be able to use your selfie just for this demo. Yeah, it's still learning. Okay. Any more questions? Otherwise, we will. I will stop here. Any other questions live, maybe from Vladimir or Marija?
I think there are. I think there are no more questions.
Let's see. We had more attendees doing the demo. No, in AutoML. One here, yawning. Okay. Okay. Do you have a question, Vladimir? Maybe one last question.
I'm not sure what to ask.
Okay, so we can wrap up. So what we've seen are pre-trained models with the machine learning APIs, and how you can extend that with the AutoML. So I hope whoever is watching on whichever platform, I hope you will have fun if you can try that. And let me know. Feel free to come back to me later on any social network. Yeah, it was fun for me anyway, so I hope you had fun too.
Great session. Thanks. I'm having some echoes. I'm not sure if you hear me good.
Yeah, I hear you well, Vladimir. Maybe it's yeah.
It's probably something on my side then. I will just wrap it up in Serbian. Hvala svima što ste posjetili današnju sesiju. Nadam se da je bilo zanimljivo i interesantno. Biće snimak na našim kanalima, tako da možete pregledati ponovo, isprobati sve. I što se tiče same Google Developer grupe Beograd, spremamo Android Study Jams, koji će biti 6-nedeljni ili 8-nedeljni program učenja Androida, tako da nam se će biti zanimljivo. Trenutno smo u pregovorima, odnosno dogovaramo mentore. Nadamo se da će uskoro biti javni poziv i nadam se da se vidimo narednom prilikom. Thank you, Laurent, once again, and see you on the next occasion.
Thank you. Have a great weekend, everybody. Bye-bye.
Ćao svima, lep vikend.